listeners to another episode of the Dark Assassins Podcast, the show that dives deep into not just technology, but the concepts, software, and procedures behind it all, and explains it so simply that even your grandma can understand it. As always, I'm your host, the Dark Assassin. You know, we talk a decent amount on this podcast about cybersecurity and the way that threat actors like to break into things and do all that fun stuff. But you know what attackers love more than easy-to-guess credentials, like a password being password or 123456? The one thing that attackers love more than that is, of course, making their life even easier, and one way that can be done is by having the credentials hard-coded into the code base. Yes, there was a story this past week where that happened, so we will be discussing that, of course, in the cybersecurity tip. But also coming up, we have I don't know if I'd necessarily call it a deep dive into Git, but we're at least going to be going below the surface level understanding of Git, which at least that's what I'm considering it to be. So it kind of getting into more of the not as widely used but still incredibly powerful tools that Git can provide. And also, does Swift, the programming language that we talked about last week in the trivia question, does Swift have a shot at dethroning C and C++ as my new favorite programming language? So all that's coming up on this episode, but first, let's get into this week's trivia question, which is, what is the name of the standard keyboard layout for English as well as other Latin script alphabets? So again, what is the name of that standard keyboard layout for English as well as other Latin script alphabets? And that is your trivia question for the week. Now, we started this episode with a fairly juicy tidbit about credentials being hard-coded into a code base. So with that, let's just roll right on into this week's cybersecurity tip. So yeah, as I kind of alluded there, the cybersecurity tip for this week is do not hard code your secrets into your code base, whether that's API keys, passwords, or other credentials, secret keys, whatever the case may be. Do not be hard coding them into your code base, because even if your code base is proprietary, if it's compiled down, which inevitably it has to at some point, and the attackers don't get access to the source code, they can do what's called reverse engineering, which essentially is a way to essentially take the executable and work out what the original source code was, or at least at a high level what the original source code was, in order to figure out what the program is actually doing. So if you hard code, secrets into your code base, whether that's passwords, API keys, secret keys, etc., if someone were to reverse engineer your code base, they would be able to see those secrets plain as day in the decompilation and during the reverse engineering process, thus completely exposing you and allowing them to get access to whatever secrets that you hard-coded in there. So there's, proof number one why you definitely don't want to be hard-coding your secrets. But number two is you definitely don't want to be hard-coding secrets if your project is open source, because if it's open source, then you just removed an extra step from the attackers, because they don't even need to put in the effort to decompile and reverse engineer your program. They can just look at your repository on whether it's GitHub, GitLab, Bitbucket, whatever, and see the secrets right there. So yeah, definitely don't be doing that. But it has come to light that the Rabbit R1, which, in case you're unfamiliar, is that AI-powered bright orange box thing that, according to basically every reviewer that reviewed it, is pretty much hot garbage. It's been discovered in a jailbreaking and reverse engineering effort of the device that Rabbits hard-coded their API keys into this device. So, oh boy. And there were a bunch of API keys to basically allow it to connect to a bunch of various different services and allow it to do queries and whatnot. So, but yeah, like I said, whether it's passwords, API keys, or other secrets, you should never be hard coding this into your source code or into version control, because you're just asking for attackers to steal those secrets and abuse them. And the reason why I bring this up specifically is in the instance of the Rabbit R1 here, one of the API keys that was hard-coded in was their API key to 11 Labs, which essentially is like a voice-to-text API that allows you to take in, voice commands and translate it into text. And essentially, if you had the API key's been changed, by the way, at this point, so you can't get access to it. But at the time when it was discovered, assuming you had this API key, you could essentially use it to see every single query that anyone has ever made with a Rabbit device. So talk about a massive security issue. So yeah, not good. So Rabbit, just when the kind of the fire was dying down from all the reviewers flaming it and them getting absolutely destroyed by, Google and Apple with their developer keynotes and essentially doing everything that the Rabbit device can do just in software. Yeah, the hits just keep on coming for them. So yeah, it's a pretty rough one. And if their implementation wasn't bad enough, the fact that you'd ask it a question and you'd be waiting multiple seconds, if not more, for a response. Now it turns out that all of the secrets that were being used for it were essentially just hard-coded in there. So really good quality piece of engineering for sure. But yeah, so let this be a reminder that you should never be hard coding your secrets into your program. And that is your cybersecurity tip for the week. So this next thing I kind of wanted to touch on is it's just going to be brief, since I didn't really have time to really flesh out my thoughts on all this. But over the past few weeks, I've seen different kinds of blog posts and articles about, in essence, the failure of the agile development process. So I think it's kind of worth a deeper discussion in the future of agile and agile. And if you're confused why I said agile and agile back to back, there's two key distinctions that need to be made. There's agile with a capital A, which is the software development process, and then there's agile with a lowercase a, which is essentially, the idea that you're being able to be adaptive and nimble and everything, which the agile development process is supposed to be. But in various blog posts and articles and whatnot, people have basically been kind of saying it's the opposite. And I guess their arguments kind of boil down to, corporate entities have kind of taken over and kind of, destroyed the original meaning of the agile development process and kind of morphed it into something else kind of to more suit their needs. Because if you're familiar with the agile development process, especially in like a professional software development environment, is the daily stand-ups that people either absolutely love or absolutely hate and find very unproductive. So, of course, this is, totally worth a deeper discussion, but essentially some argue that the daily stand-ups are essentially just a way for management to micromanage, not necessarily micromanage, but basically babysit the developers and make sure they're staying on task and doing what they're supposed to do. So from that perspective, of course, management's going to love this practice because they get daily insights into what their team's doing to make sure they're actually doing what they're supposed to, and they're going to meet their deadlines on time and all that good stuff. But even from the developer's perspective, it could be good for the developers because it gives you a chance to kind of get together once a day and, go over any kind of problems you're running into, or if you have any issues, that kind of a thing. But I would make the argument, kind of the devil's advocate counter argument to that is, well, if you find an issue that you're running into, you shouldn't be waiting for the daily stand-up to bring it up, right? You should be, actively, reaching out to other developers on the team to try to get their, insight into, what your issue might be and if they can't, help you figure it out. But this kind of, I guess, goes back to another point that I kind of, I guess, just thought of, in some of these articles where they talk about the agile development process. So you have, like, I guess, it seemed to me, based on reading some of these articles, that there's kind of like two different types of daily meetings. So you have like the one kind of dailies, which is pretty much bland, boring. Here's what I'm working on. Here's what I plan to work on. Here are any issues that I have. All right, next person. And those are very monotonous, let me tell you. But then there's the other types of daily meetings where, yes, you kind of go into, what you're working on and whatnot, but essentially it's more of a, not necessarily a get-together hangout session, but it's also kind of a get-together hangout session because, like, for instance, I've kind of been a part of a couple different agile processes with the different companies that I've worked for. The one was, I was like doing an internship, and they had, of course, they're practicing, the agile process, doing DevOps, all that good stuff. And part of their daily meetings was, yes, we went over, what we're working on, what we're planning on working on, but a decent chunk of the daily meeting was pretty much, just chit-chatting and, talking, kind of having, not necessarily like a brain break, but just, kind of getting to know each other, having some, interactions with each other, face-to-face interactions, whatever. And it was honestly kind of nice, helped you to get to know your team and whatnot. And then on the flip side, I've also been in kind of the reverse side of things where it's just strict, this is what I'm working on, this is what I've been working on, don't have any issues, then moving on to the next person. And those are definitely not as enjoyable. Now, I guess there's kind of you have I guess you have two camps, right? So, of course, at least in my opinion, as a developer at heart, I despise meetings. I do not like meetings. I just want to be able to sit at my desk and write code. That's what I want to do. That's what I'm good at, and don't interrupt me. Don't bother me with meetings, right? So if you're making me come to this meeting that is very bland and boring, I'm not going to enjoy it. But on the flip side, if it's, actually entertaining and I can, get some good value out of it, then nice break from working on code, give me a nice break. But you also have other people where, I'm not trying to say that this is good or this is bad. You can make your own assumptions, but some people are of the idea that they essentially don't want to or don't care to get to know their coworkers, and they're just of the mindset, I work with you, and that's the only level of relationship I want to have. I don't want to know anything else about you. If you have issues, you can come talk to me, like if it's work related, but other than that, I don't want to hear anything from you. So there are those people out there. But then there's also the other people on the other flip side that want to know like everything about you and want to be like best BFFs, essentially, like even outside of work. So there's kind of the two extremes, and I guess you could say the majority of people kind of fall somewhere in the middle. But so depending on who you are, the super strict, to the point, this is what I'm working on, this is what I plan to work on, etc., could be appealing to some and not appealing to others. And then on the flip side, the one that's kind of more of a 15 or 30 minute or however long your dailies are, kind of hangout session, if you will, where you just kind of, see how everyone's doing, and then, oh yeah, you happen to talk about work in there too and what you're working on. Some people enjoy that more, some people don't. So it just kind of is, I guess, what you're into. But yeah, so I think, but part of the getting back to the point here, some of the issues that are kind of getting brought up in these articles is the fact that the agile development process has kind of moved away from the original goals of being agile and being nimble and all this. Because in some of the corporate environments, the agile development process has essentially just become just as rigid as waterfall was, just with more frequent releases. So the big thing with waterfall was, you start with like your requirements planning, and then you move down to like your design phase, and then your development phase, then your testing phase, and then eventually the release. And it's like this trickle down waterfall of everything kind of moves in a very linear, slow process. And you get your, whether it's 6-month release or your yearly release or whatever your release cycle is, you follow that process every single time. And kind of the point of agile was to be able to deliver at a much more frequent interval. And if something were to come up during the development process, like you need to quickly shift tasking to be able to patch some critical security vulnerability, for instance, you have the ability to be flexible and agile and be able to do that, rather than being strictly following this schedule that, Waterfall was kind of known for. But it seems like that kind of, I guess, in recent years, Agile has essentially become Waterfall, just, more frequent with, more frequent releases and the additional overhead of, all the daily meetings and all that stuff. So specifically, one of the blog, I think it was an research article or something that came out recently, claimed that agile projects have a 268% higher failure rate, which I think is what has kind of sparked a lot of these, articles and blog posts popping up recently about the agile development process. So again, I think it's definitely worth a deeper dive into the agile development process. I know maybe a few months ago we kind of talked about microservices versus monoliths, kind of those kind of design philosophies. So might be probably worth doing an episode specifically on agile. But I am interested to hear what your guys' thoughts are, especially if you're software developers working in agile development environments and working with that principle. I'd be interested to hear what your views on it are, since I know some people have very adamant views on it. So I'd be very interested to see if you've worked in an agile, environment before, and if you have, what are your thoughts on it? So you can either email me at contact@darkassassinsinc.com. There's a link down in the show notes below. Or if you're on YouTube, you can just leave a comment. And if I get any interest, any takers for giving their input, I will definitely be sure to include those in a future episode. And with that, let's move into what nerdy stuff have I been up to this week. So this week, I was writing a fair bit of Swift code. So as I kind of alluded to at the top of the episode, is Swift going to take over and dethrone C and C++ as my favorite language? Well, we'll get to that in a little bit. But I actually had this thought as I was writing this Swift code that real Swifties write code. And of course, when I say real Swifties, I'm of course referring to the Swift programmers, not the potentially more widely known term of Swiftie, which is like Taylor Swift fans or something, maybe. So, I was also thinking, when I came up with that line, that real Swifties write code, I was thinking of making that the title for this week's episode, but I'm, not a clickbaiter, and that probably would have caused some intrigue, I would say, from a different community, and I might not necessarily be hitting the audience that I wanted to reach, so I, of course, didn't go that route. So you are welcome that the title of this episode is not Real Swifties Write Code. But like I said, I was getting into writing some Swift code again, and in case you're wondering, no, I was not working on an iOS app, and I was actually just writing, desktop, not necessarily desktop applications, but kind of like desktop / command line based applications. And also, in case you were wondering, yes, I was writing Swift code for Linux too. So while, yes, I would say Swift, for probably good reason, is mostly associated with Apple and Apple devices, you can also build and run Swift code on non-Apple operating systems. Now, granted, it's not as straightforward of a process to get it up and running. Like, for instance, if you want to write Swift code on, Mac OS, you can easily just, as long as you have Xcode installed, you can build Swift applications, right? But if you're on Linux, depending on which operating system, which flavor of Linux, I guess I should say, that you're running, you may or may not be able to easily get Swift installed. Like, for instance, I was using Red Hat at the time that I was playing around with this, getting it up and running. And, of course, there is no, Swift package included with the package manager. So I basically had to go download the tar.gz file that Apple provided and essentially extract it and allow it to kind of do its various sim linking and everything, and then update my path accordingly in order for the Swift compiler to be included in the path so I could actually compile Swift programs and Swift code. So granted, it wasn't necessarily all that complicated, but it's not nearly as straightforward as you literally install Xcode and you're good to go, or you do something like, DNF install, GCC, or apt install build essential, or whatever the case is, to install your stereotypical, I guess, programming tools and compilers and all that good stuff. So anyway, I guess getting back into actually developing Swift. So I have, over the past few years, well, actually maybe more than a few, kind of back in college was really when I first got into Swift, because back in college I had this idea that I wanted to write iPhone apps, and the only way to do that is, first, you need a Mac, and two, well, I guess at the time Swift was kind of still in its infancy. Around, like, it was definitely around, but it was definitely in its infancy, and Objective-C was still, I would say, probably the dominant programming language for iOS apps. But when I first wanted to try to work on iOS apps, my first hurdle was that I needed a Mac, because back at this time, I was not a Mac OS user. I was a hardcore Windows user, and I clearly remember not wanting to get a Mac for college because it was a new operating system and I didn't want to learn it, and I just wanted to use Windows. But I remember the computer that I ended up getting, one of the reasons why I wanted it was because it had backlit keyboard, which I was like, that's kind of Mac-like. So yeah. Boy, oh boy, young dark assassin didn't know what he was missing. But anyway, we got there eventually. But yeah, so of course, that, like I was saying, Swift was kind of still in its early days, but that's what really first got me into Swift, was wanting to write iOS apps, because I had tried dabbling with Objective-C initially, and to be honest, I didn't really like it much at all. But also back then I was still very new to programming in general, And at that point, almost all of my experience was Java. So yeah, I wasn't necessarily a huge fan of Objective-C. Maybe if I went back to it now, I might have a different opinion. But, with how much Swift has kind of taken over, I'd say, the iOS and macOS kind of ecosystems and all the really Apple apps in general for developing applications. I don't think I'll ever go back to trying to learn it. I think will just always be my go-to when writing apps and that stuff. But back to the point, the reason why I first started using Swift, and in the past, the only reason I've used Swift was whenever I wanted to write the occasional basic iOS app, and then I would essentially never touch it again until I got either motivation to write another iOS app, or I wanted to really this time for sure learn how to write iOS apps. But it was always a very spurty and sporadic thing, and because of that, I never really fully got into the language and really learned the ins and outs of it. But since actually being able to write desktop and command line based applications, it's really gotten me writing, I would say, more Swift code, because when you're writing iOS apps, at least for me, most of the apps that I was writing were very, very basic apps, and a lot of the Swift code I was writing was mainly just like GUI based stuff to essentially add text fields and buttons and that kind of a thing. So there wasn't like a whole lot of your typical programming, right? I wasn't really doing a ton of like algorithm based stuff, or doing a bunch of user input handling, or doing any kind of networking, although I did do some iOS apps with networking. But my point here is I didn't necessarily have a bunch of, hardcore programming type programs with it, right? Most of it was kind of like GUI based programming and didn't really get into the weeds of Swift, if you will. But actually writing, desktop and like command line based programs, I've really gotten deeper into that stuff, learning about how to write algorithms in Swift, working with the data structures, how does sets work, dictionaries, arrays, all this good stuff. The kind of the core fundamentals that you need to know when you're first learning a language, and actually being able to use them and really dive into it. I've been really enjoying writing Swift code, if I'm being completely honest with you. Because one thing that I've noticed is it's very clean looking, and I would also argue it's pretty easy once you kind of get the hang of things. Like, for instance, for loops are very Python-esque in my opinion. So if you've ever written like for loops in Python, it's very similar kind of syntax, if you will, in Swift. So in Python, like the common thing is if you have like an array called array, the very common for loop in Python is like for a in array, and then you do whatever your loop's doing. It's basically the same thing in Swift. So very easy to pick up, at least in my opinion, but definitely take that with a grain of salt, because this is also coming from someone that has been writing code for almost 10 years at this point, and has written in numerous programming languages over the years, from Java, Python, C, C++, HTML, if you can even call that a programming language, regrettably JavaScript. I've dabbled in a bunch of various different programming languages over the years. So for me, picking up a programming language isn't all that difficult as it would be for like a new programmer. And the reason why I say this is because when you're first learning programming and software development and software engineering and all this good stuff, a lot of the initial problems that you run into is you don't know how to tackle the solution, right? Like it's kind of like if you get thrown into something and someone just spits out a bunch of information at you and asks you if you have any questions, but you have no idea, what they just told you. So you essentially don't know what you don't know. And that's kind of the issue that new programmers run into when they're first learning, programming, right? Since when I remember when I first started learning, one of the, the hurdles was, yes, you have to learn this completely foreign language to you, number one. But number two, you kind of have a basic idea of maybe how you want to solve the problem, but you don't know, what to do to accomplish that, right? Like, okay, yes, I want to, get this element in this linked list, but how do I actually do that? I don't know. I'm a new programmer. I've never dealt with linked lists before. How do you do that? But once you've, written code for a while and you kind of understand, the various algorithms and data structures involved and, the various concepts of loops and conditionals and all this good stuff, you understand what you need to do to accomplish what you want to accomplish. All you have to figure out is, okay, how do I do that in this programming language? So if you already know, like, we'll go back to the linked list, right? So the typical way that you get to the nth element in the linked list is you essentially do a while loop and just iterate over each node in the list and kind of, I'm at this point, and then, all right, so now I'll set that point equal to the next pointer, and then to the next pointer, and to the next pointer until I find the value that I want. But if you're a new programmer, you don't necessarily know that. So you have to, one, figure out how that works, and two, you have to figure out how while loops work and, all this good stuff. So there's a lot more that you have to learn when you're learning your first programming language. But once you already know a programming language and you kind of understand the concepts behind it, at that point, it's just, trivial to learn the new syntax and kind of figure out the little quirks of the language. So for me, that's why I said that it was pretty easy to pick up. Now, I would say one of the easiest programming languages out there is probably Python. And a lot of people agree that it's one of the easiest languages. And generally, I would say nowadays it's kind of recommended that people learn Python as their first programming language due to the ease of the syntax, and kind of the relative easiness of it to learn, and kind of all the various things you can do with Python. But for me, I never learned Python before. It was just something I kind of picked up on my own. And to me, it was very easy to learn, one, because, the syntax is really easy. But when I was learning Python, essentially all I had to do was figure out the syntax and kind of the quirks of the language. Like, you don't use semicolons and you don't use brackets to specify, brackets of code. You do tabs or spaces instead, those kinds of things. So those are the things that once you've been programming for a while, those are the things that you pick up. And generally it comes fairly quickly. And because you already know kind of the logic of how you want to do it, it essentially just comes down to, okay, how quickly can I, get into memory, the various quirks and syntax, and okay, and, in this language, it doesn't use append, it uses pushback instead, or, the minor kind of quirks like that. So anyway, getting back to Swift, I guess, I've been kind of praising it here, saying how easy it is to learn, and now that I can write desktop applications, the big thing that I've actually been wondering is, what can I write in Swift? So I've been kind of toying with the idea of what I want my next kind of project to be. And I know, yes, I've been working on a video game off and on, but it's kind of been put to the back burner because Swift has taken over for the time being. Of kind of what I want my next project to be, kind of little side project that I do. But I was kind of thinking whatever I do for the next thing would be a Swift variant. And one of my kind of thoughts was to do another implementation of my elite encryption algorithm, but instead this time do it in Swift, to add to the collection of Java and C variants. So currently, is Swift going to dethrone C and C++ as my favorite language? No, at least not yet. And quite honestly, I don't think it will, mainly because the niche that Swift has because pretty much, at least kind of what I've seen, unless you're doing specifically iOS development or macOS development, you're not using Swift. And even if you are doing development for some of those platforms, sometimes you're not even using Swift and you're using some other language. I think Flutter might be one of them, or like some kind of JavaScript variant that you can then like do some shenanigans to get a cross compile version, like essentially kind of creating like a what are they called, like are they mobile web apps? I forget what they're called, but essentially like you basically make a web application into a mobile app type of a deal, and you can write the thing in JavaScript and then get it to run as an app on Android and iOS, which kind of sounds like an abomination to me, but it's something you can do. And the appeal there is you have one code base and you can get applications on Android and iOS. So I guess on the one hand that's nice, but at the other hand it's like running Python code versus writing a program in C that compiles down to machine language. Yeah, the Python program is going to work, but the C program is going to be way more efficient and way more performant. Which is, so writing programs in the native language of an operating system does have its perks. But kind of, I guess, getting back to the point again, man, I've been really getting sidetracked in this episode. I don't necessarily think Swift could take over, mainly because there's a lot more utility, at least in the industry, for languages like specifically C++. C is, I mean, unless you're doing like embedded stuff, you're probably not going to touch a lot of C code. But I mean, there's so much of the world's infrastructure has C and C++ code bases. So there's going to be a lot of use cases for those skills. And I'm just not sure I could, unless I was really, really searching hard specifically for a Swift position, I don't necessarily think I'd be writing Swift code professionally. Although that could change in a few years. I don't know. I guess we'll see. But I would also argue that I definitely am not a master of Swift and could, get a high-paying software development job specifically for Swift, since personally I don't have the Swift background yet. But like I said, I'm learning, and kind of, that's one of the processes of learning new languages. You got to start somewhere, right? And really the core is just to have the principles and understanding of software development, software engineering, and that will aid in the ease of learning new languages. And speaking of writing programs and writing code, we've talked quite a bit on the podcast about why you need to be using version control for your software development projects. And this main one that I like to talk about is Git. And over the years, Git has kind of become the market leader. It didn't used to be, but it has since kind of become the I guess the standard when it comes to version control, especially in the software development world. And you honestly don't even need to be a developer in order to use Git, because all Git is at the end of the day is a version control system. So essentially, if you take any kind of file, it doesn't even have to be a source code file. It could be an image file, or it could be a Word document or an Excel spreadsheet, or whatever the case may be. You could throw it in version control, and if you ever run into an issue, you could easily roll back to a previous change, and revert back any broken things, whatever the case may be. So anyway, you don't have to be a developer to use Git, but if you are a developer, you definitely should be using at least some form of source control that isn't copy the entire source code, paste it, and call it backup until you get your changes working the way you want them to. That is not a good version of version control. But getting back to Git here, one of the, I guess, complaints that a lot of, especially new programmers, have when it comes to Git is how complicated and sometimes convoluted it can be, and tricky when you're at least first learning it. And I think part of this has to do with the fact that Git is primarily a command line tool. So, especially in this day and age where everything has some kind of GUI or graphical user interface, using command line programs isn't necessarily as common knowledge and first nature as it used to be, back in ye olden days when your operating system was literally just a command line interface and that's all you got. So back in those days, everything was a command line program, so it was a lot easier and more natural for people to get accustomed to how those things worked. But nowadays, some people, if there's no GUI attached to it, they're not interested in using it no matter how good the program is. So, but with that said though, there are tools that there are GUI tools that essentially wrap around Git to try to make it an easier experience. And of course, yes, there are things like remote repo softwares out there like GitHub, GitLab, Bitbucket, Git, etc. But in all honesty though, you don't even need one of those solutions to have a remote Git repo. Like, you could literally create a bare repo on like your NAS or some other computer in your house or in your corporate network or whatever, or even on a flash drive, and use that as a remote repo and just push and pull from it like you would, from GitHub, for instance. So Git is essentially and primarily at the core essentially a command line based program, and these other, more pretty versions is just to try to make it easier to use. But I wanted to kind of do a little bit of a deeper dive into Git, because when you first learn Git, of course the basics and what I would consider the surface level are your git add, your git commit, git push, and git pull, and maybe to a lesser extent git fetch. But those first four, the add, commit, push, and pull, are kind of your bread and butter when it comes to using Git, because if you don't know those, you should probably learn those first as your starting point, because first, git add is what you of course have to do to add any new file or add any stage change to actually be ready to commit. So for instance, if you have a Git repository set up and you create a new file, let's say we'll call it test.c for instance, if you don't run a git add on that file, it's not going to be put into version control. So that's the first thing you have to do. And then every time you make any changes to it, you have to re-add it so it can be, those changes can be staged, and then you can commit those changes to version control. Now you can, if you've already added the file once, you can do you can do some things with git commit, like you can tack on a -a to essentially add the files themselves, so you don't have to always do the add portion separately. And then of course you have your push and pull, so whenever you want to sync your changes with a remote repo, you can either push those changes if you made changes to send those up to the remote repository, or you can do pull to pull those changes down. Now the big difference between git pull and git fetch is pull essentially tries to pull everything down and, put you forward to be wherever the remote repository was. So for instance, if the remote repository had 2 additional changes that you didn't have, pull would pull those directly down and leapfrog you essentially to those 2 new changes. The thing with git fetch though is it pulls essentially where the remote repository is, but doesn't necessarily jump you to that new location. And the reason why this is important is if you ever run into an issue where your histories are diverged, git pull can either fail or make you have some kind of merge conflict, where git fetch you can kind of pull those changes down, kind of see what the differences are, and you can do it kind of in a more manual way. So there are some benefits to git fetch. Personally, one thing that I've used it frequently for is there have been times where I have rewritten large parts of the Git history and then trying to pull it onto another device, and it doesn't work because the histories are out of sync and the pull just cannot complete successfully. So what I have to end up doing is essentially do a git fetch to pull down where the remote repository is, and then essentially reset the head of my Git repository to point to the remote repository to get me on track so that I can continue to push and pull. So there are some differences to fetch and pull, but those are, for the sake of this, that's, I guess, as far as we're going to get into them. But those are what I would consider kind of the surface level understanding of Git. But where we start to get a little more interesting is in what I would, I guess, consider a little more advanced workings with Git that you probably don't use on a daily basis, because if you're a developer, those four that we already talked about are probably the ones that you're going to be using the most frequently, and probably on potentially even a daily basis, at least for the commits and the adds. Maybe not necessarily the push and the pulls, although you should be pulling relatively frequently just to make sure you're up to date. But getting into some of the more advanced ones, specifically bundles, merging, branches, cherry picking, and rebasing. So some of those might sound kind of scary, specifically the merging one, but the one I want to start with is bundles, because that might be one that people might not have heard of before. So let's first start off with what bundles are. So when you do a git push, or even a git pull for that matter, but we'll stick on push here, what's really going on behind the scenes is Git is essentially determining when you last pushed to the remote repository in order to calculate what commits it needs to send to the remote repository when you're doing a push and a pull. Now, of course, that is an oversimplification of what's going on behind the scenes, because, for instance, when you're trying to, say, push to a remote repository, or pull down, if your Git histories don't match, you'll run into issues. If your Git history is behind the remote, you'll run into an issue saying you can't push, so you need to pull and merge the changes first. So, of course, there's more to it than that. The point is, that's kind of what Git bundles are doing, is you can kind of think of Git bundles as this manual process of a Git push and pull, in the sense that when you create a Git bundle, you're essentially doing that process of figuring out what commits to push, if you will, in order to package those up into a single file. So when you create a Git bundle, essentially what you first do is you specify what commits you want to add to it. So you can specify the entire source control history, or you can specify only the past 5 commits, the past 2 commits. You can specify a range of how many commits you want to put in this bundle. And then once you decide that, it will be packaged up into a single file. And then what you can do with that file is you can, send it to someone, put it on a shared drive location, or whatever the case may be. And then on a different device, you can use that bundle and essentially pull from it like you would from any remote repository. So the only catch here is, because you're only bundling potentially a select number of commits, you don't have the full Git history there, so you could fairly easily run into an issue where, if you're pulling a bundle that has, say, the most recent 5 commits, but your local repository is 6 commits behind, you're going to run into issues because you're missing part of the commit history. So one way that you can potentially alleviate some of this issue is by cherry picking commits. Now, it can work sometimes, like for instance, if you have diverging history, you can pick the commits that won't interfere with that diverging history. The problem is you have to be careful here, because if, like I said, you are, say, 6 commits behind, but the bundle's only 5 only has the most five recent commits, yeah, you can cherry pick those 5 recent commits and include them, but you're still missing that one commit, which could potentially break things in those 5 future commits. So that is one thing that you have to be careful of, is noticing what is all included in the bundle, and ensuring that you are in line with that. Now, one thing you can do is there's a verify flag that you can also tag on to bundles to essentially check to make sure that where the bundle is required you have in your Git history, that you actually have that in your Git history, so you can easily merge that in or pull it down or whatever the case may be. So why would you use bundles? Why not just use remote repositories like normal people? So for starters, if you need to transfer code to someone, I would argue it's better than zipping everything up and sending it to them that way, because if you have to zip up the source code every single time, that could, depending on how big your code base is, that could be a rather large file and take a long time to zip up and decompress it, compress and decompress it. And depending on how you're planning on sending it, that could also be a rather large file that you might run into issues trying to send. So the nice thing with bundles is you're only sending the changes that have been made, so your file size is going to be a lot smaller, so you can easily transfer it around. Plus, both you and the person on the other end will have the entire version history of the source code. So, if they need to roll back any changes or view previous commits, they can do that without just having the raw, source code files. So that is one benefit, that it's a lot easier to share, version history and whatnot. But the other benefit too is if you have a machine that, say, doesn't have internet access, or for whatever reason you can't share a remote repository, you can just use bundles in order to transfer, essentially transfer the Git repository, if you will, between machines. But also you can do offsite backups too. So even if you do have a remote repository, for instance, say you're self-hosting it and you're paranoid that or maybe a ransomware attack will come in and completely compromise your Git repo. If you're doing periodic bundles of your Git repo, you could potentially store those either off-site somewhere or on a flash drive or external hard drive or whatever the case may be. And then if you ever have some kind of outage, like your Git repo goes down for whatever reason, you still have those bundles that you can essentially pull from and act kind of as your remote repo, even if you don't have physical access to the remote repository. So, and kind of like I said, the other kind of benefit too is you can select which commits you want to include. So you can also divide up your commit history into smaller chunks to potentially make transferring larger repos easier, at least in the initial stages. And then once both sides are all caught up, like I said, it's a lot easier to just give them the new changes in a Git format rather than here's the new source files or here's the entire project again, include them, good luck. Because one of the big issues is if you make changes to, say, one source file, but the other person you're working with is also making changes to that same source file, if you're just giving them the new file, they have to manually go through and check, okay, is any of the code that I'm changing messing with their code? If you're doing a Git bundle transfer that way, assuming you're not touching, the same portion of the code, like if they're working on function foo, but you're working on function bar, you're not going to run into any issues, and then Git will easily be able to just merge those changes together and you're good to go. So that is another reason why sending Git bundles rather than just sending the raw source code files is definitely a benefit. So those are bundles kind of in a nutshell, why they're good and why you might potentially want to use them. And the next one I kind of wanted to touch on, we kind of touched on some of the others, like cherry picking, for instance, which is where you essentially can pick which commits out of a commit history that you want to include. So now I wanted to touch on rebasing. So rebasing is pretty cool because it essentially allows you to modify large chunks of your history all at once. So you can easily change things like a series of commits, modifying the history of your repository, reordering, editing, or squashing commits. Now, it goes without saying that you need to be very careful whenever you're messing with your commit history, especially if you're collaborating with other people, because depending on what parts of the history you change, you could essentially brick other people's version of the code. The big one here is like this is why people generally don't recommend you force push to a remote repository, because if you are force pushing and overwriting changes in the remote repository, if someone tries to then pull changes down, your histories are going to be different and you're going to be in a real mess. So the same thing goes with rebasing too. If you're not careful, you can get into a real mess and potentially brick things for others. So you really have to be careful with it. But it's very powerful because you can do a good amount of stuff with it. So for instance, if you merged or committed changes out of order, that could potentially cause issues if you ever need to roll back for some reason. So one thing that I always try to do, but sometimes don't necessarily work, it doesn't always, work as I intend, is ensuring that commits happen in order. And what I mean by that is if you make a change to function A and function B relies on function A, you want to make sure that your changes to function A occur in the Git history before the changes in function B. So if for whatever reason you need to roll back changes, you don't essentially remove something that another function is depending on, right? So if for whatever reason you accidentally did that and you committed the changes for function A after the changes for function B, but function B relies on function A, that would be a case where you'd want to do a rebase and kind of reorder and edit the change history of your Git commits to essentially ensure that if you ever need to roll back changes, you're not removing functionality from a function that needs it. So that's one of the reasons why you could use rebase to reorder commits. Similarly, squashing commits is essentially this idea of taking multiple commits and essentially combining them into a single commit. Now, the reason why you'd want to do this is kind of typically if you're merging your local changes on your dev branch into like the mainline branch, for instance. And the reason why you do this is, so for instance, ideally, when you're working on your dev branch, you've done all the testing and everything to make sure that your new feature, whatever you're working on, works like it's intended to. So the idea of squashing your commits is essentially creating a single commit that gets merged into the main line. So for whatever reason you need to roll back changes in the main line, you don't roll back to a change partway through your commit history and not include some of the fixes that you added or some of the parts of the feature, and essentially also squashing the commit history also has less bloat in the history. Now, it also goes without saying that this doesn't mean that when you're working on new features, you should only have a single commit at the end once everything's implemented. That kind of defeats the purpose of the source control. But the point of the squashing is essentially to make merging and rebasing and rolling back of changes a lot easier, because if you only have one commit essentially in the main line, if you will, for your feature, it's a lot easier to roll back to a previous point and ensuring that all your changes, you're not missing any of those changes, right, when you're switching around and swapping around the history. So that is one of the reasons why you'd want to potentially do a rebase and squash your commits down. Another cool thing you can do with rebase is you can change the author of commits too. Now, I'm not bringing this up to tell you that you should claim other people's code as your own. Definitely not. On the contrary, the reason I bring this up is because I've been in this case where I've been working on code that, say, I'm either pushing to my local GitLab instance, or I've been just working on changes locally, and then I want to push it to my GitHub, but my username and email isn't correct. So what am I going to do? I can nuke the whole Git repo, which I don't want to do, and start fresh with the correct credentials. Or I could do like a filter branch type deal and do it that way. But if I want to make sure my commits are signed, like for GitHub, doing the filter branch doesn't work. So what I can do is I can do a rebase and change the author and essentially ensure, and the other cool thing with this too is you can also ensure that the timestamps and the commit messages also remain the same. So essentially you can redo the author and essentially sign all the commits and make sure everything's good to go before you push the changes. Because one thing, I guess it depends on how you have your GitHub set up, but for me personally, I have my GitHub set up where if I ever try to push changes that I accidentally include my actual email address as the commit email, it will essentially flag it and not allow me to push the changes. So in cases like this where I might have done that for a few commits because I was not seeing what what credentials I was using for the local Git repo, I could just do a rebase here to change the author but not actually modify the timestamp or the actual message, and then be able to repush those without issues. So that is another way where rebase can prove vital. So those are kind of the big kind of diving deeper into Git that I kind of wanted to touch on. And hopefully you picked up a few things on this. Maybe you can either use it in your own personal projects, or if you write software for a living, maybe you can incorporate some of those into your job. I mean, for me personally, like before I kind of did this deep dive into Git, I had heard about bundles and I had maybe used it like once or twice before, but actually playing around with them and actually getting to use them, they are quite nice, let me tell you. And discovering this whole thing with Rebase was absolutely a game changer, let me tell you. So I definitely learned something doing this kind of a deeper dive into Git. Hopefully you also learned something from this deeper dive, and if you did, definitely be sure to subscribe, like the podcast, all that good stuff, share it around. But before we close out for this week, let's get back to our trivia question. So, what is the name of the standard keyboard layout for English as well as other Latin script alphabets? If you said QWERTY, you are correct. And I guess a bonus trivia question is, how did QWERTY get its name? How did the name QWERTY come about? So if you actually look down at your keyboard, you can see QWERTY, or QWERTY, are all in a line at that top row of the letters. So that's kind of where the name comes from. So hopefully you got that one right. Depending on who you are, that might have been quite the softball this week. But regardless, I hope you enjoyed the episode. And if you did, definitely leave a rating and review, like, comment, subscribe, all that good stuff if you haven't done so already. And be sure to share with a friend or family member, especially if someone's new to Git or programming in general. We talked about some topics that would be beneficial to them, I think. But if you have any questions or topics or ideas for future episodes, or like I mentioned earlier in the episode, your thoughts on Agile, I would definitely like to hear those. So be sure to either send me an email at contact@darkassassinsinc.com. Again, link is in the show notes below, or you can leave a comment if you're on YouTube. And that's going to do it for me in this episode of the Dark Assassins podcast. Until next time, my fellow assassins, remember, bool nothing equals true. If action not equal to null, return true. I'll see you next time on the Dark Assassins podcast.